Hello, in these videos we find the Laplace transform of each of these given functions. So Laplace transform we denote by capital F. And what we do is we can use a table where we can write down formulas or have formulas, and we can reference this table. Here's f of t and capital F of s. So the Laplace transform of little f is capital F. So this table you could write over here, L of f of t. And you can look up tables with a web search and see one under images. And so what we can look at here is that if you have e to the at, then the Laplace transform is 1 over s minus a. That's equivalent to Laplace transform e to the negative at is 1 over s plus a. So the first one here we have e, 3 Laplace transform e to the negative 2t is 1 over s plus 2. Then we also have that Laplace transform of t to the n is n factorial over s to the n plus 1. And so then in particular, t squared has Laplace transform 2 factorial s to the 2 plus 1, which makes 2 over s cubed. There's restrictions on s, but I didn't write those down. For t, using this same formula, the Laplace transform of t is 1 factorial, which is 1, over s, 1 plus 1 is 2. And the Laplace transform of 1 is really actually using the same formula where n is 0, is 1 over s. So this formula for t to the n, Laplace transform applies when n is an integer. So that's what we get for that Laplace transform. It gets a little more involved in the next one. So let's continue on the table here. Now, for sine of bt, we have a formula for the Laplace transform, which is b s squared plus b squared. But with all our, everything we have, if you have e to the at times a function, f of t, and then find the Laplace transform, this becomes f of s minus a. So therefore, e to the at sine bt is b over s minus a squared plus b squared. So we replace s in the sine bt formula by s minus a, and that's because we multiply by e to the at. So in this case, we apply that formula and we get 6 over s minus 3 squared plus 6 squared. So using the formula, this is saying that a is 3 and b is equal to 6. Then for t to the third power, we use this t to the n, and we're going to get minus 3 factorial. So in this, for this case, n equals 3. And then s 3 plus 1. And then e to the t, well, that has Laplace. There's a formula for e to the at. That's 1 over s minus a. Oh, I already wrote that above. Anyway, so here we have e to the at. Laplace transform is 1 over s minus a. So this will make 1 over s minus 1. And I can just try to make that look a little better, slightly simplified. 3 factorial, remember, is 3 times 2 times 1. So that's 6. And that's 6 over s cubed plus 1 over s minus 1. So we get that. And adding on to our formula list that we have cosine bt is s over s squared plus b squared. And if we multiply by e to the at, then we get the same formula, but we shift this to s minus a on the numerator, s minus a squared plus b squared. That was weird. Like, what the heck just came up there? I don't know. So, okay. All right. So then we have the Laplace transform called capital G. So here A is equal to -2, B is equal to radical 3. So we get so we get S, but we shifted. S minus -2 makes S plus 2. Then S plus 2 squared plus rad 3 squared. And then minus, oh, actually, see, we have the same idea for a shift of t squared. So need to maybe extend this, but it's going to be a little, I don't know where. Extend this down here. Okay. So we said before that t squared is Laplace transform of 2 factorial s to the 2 plus 1 is s cubed. And 2 factorial is just 2. So we wrote that above already. But if I multiply by e to the at, then I just take all this, everything where I have s, I write s minus a. So this is going to be 2 over s minus -2, so it's s plus 2 to the third power. Just one more line I could multiply out rad 3. So I get s plus 2 squared plus 3 minus 2 over s plus 2 cubed. Okay, so that's the Laplace transform, and it's done using tables, not a definition of Laplace transform. We did all those by using tables.